Hello and welcome. In this video, we're going to be looking at questions involving implicit differentiation. We're going to be talking about what is implicit differentiation and how to differentiate using implicit differentiation. So let's start by saying, let's say we have a function y equals 2x squared plus 3, and I want to get the differentiation. It's basically dy by dx is going to be 4x plus the differentiation of 3 is 0, so it's 4x. This is an example of explicit differentiation. Explicit differentiation is when we have y, okay, and everything is y is the subject and everything is in terms of x. So we have one variable as a subject, and then we are differentiating with respect to the other variable, okay, which is x, which is on the other side. So this is called explicit differentiation. However, implicit differentiation looks something like this. So let's say we have this question over here. 2x cubed minus 2y squared equals 5. If we try to compare this and this, we can see that here y is the subject of the formula and it's in terms of x. However, here y is implicitly put in the equation, so it's inside the equation. It's no longer the subject. Okay, so some of these you can rearrange them, okay, to make y the subject and then solve explicitly, but some others we have super difficult equations where you cannot find y to be the subject and solve explicitly. So we must find a way in order to solve this implicitly. So let's try and think how. Okay, let's say we want to find the differentiation with respect to x of x squared. This is super easy. We know that this is going to be 2x, which is power times coefficient, and then reduce the power by 1. By the way, I've done a whole series on differentiation and how to differentiate. I'll leave the link on the top right. You can check those videos which address differentiation from the beginning, from the fundamental concept until over this video, which is implicit differentiation. I'll encourage you to go check it out. Okay, so this is the differentiation of x squared. What about differentiation with respect to x of y squared? So we're differentiating with respect to x. This is going to be 2y. Okay, so normal differentiation, so I'm differentiating y as if it was x. However, I need to multiply by dy dx. This is the differentiation of y squared with respect to x. It kind of looks like the chain rule, because let's say if I have differentiation of sine 2x, okay, so this, if I called y equals sine of x, okay, so basically this is or sine of 2x, okay, so this is basically the same thing. Okay, I'm differentiating y, correct? So if I want to use the chain rule to differentiate, this over here is going to be differentiation of sine, so it's going to be cosine 2x, and then differentiation of what's inside, so we multiply by the differentiation of what is inside. So differentiation of 2x is basically 2. Okay, it's the same thing. Here it's considered as some function similar to y equals sine 2x. So we differentiate using the chain rule. So we differentiate the whole thing, so 2y, and then we multiply by the differentiation of what's inside. And what's inside is y. Differentiation of y is dy by dx. This is basically the concept behind it. Or practically, what you will use is whenever you see a y, okay, and you're differentiating with respect to x, you differentiate it normally and then you multiply by dy by dx. Okay, so let's try and solve this example over here. So let's say we want to find the differentiation of this whole thing. So differentiation of this whole thing. Okay, so to differentiate that, what we will do is we will differentiate each term. So 2x cubed differentiated is going to be 6x squared minus, okay, this is a term involving y, so I will do exactly as what I did in the above example. I'll differentiate it normally first, so 4y, and then I have to multiply by dy by dx equals, what's the differentiation of 5? It's basically 0. And then from here, I can solve for dy by dx. So 6x squared, I'm going to move this to the other side. It's going to be 4y times dy by dx. Okay, so dy by dx, I'm going to divide 4y both sides. So dy by dx is going to be 6 over 4, which is 3 over 2, x squared over y. So basically, this is the answer for dy by dx, and this is how to find it using implicit differentiation. Let's take another example. Say this is the second example. Let's say we want to differentiate 3x plus 2x squared y squared equals 1. Again, we'll start differentiating each term. So differentiation of 3x is 3 plus, okay, 2x squared times y squared. This is an example of the product rule, remember? So if we have an f multiply g and I want to differentiate it, okay, it's going to be the differentiation of f times g plus the f normal times the differentiation of g. So here, my f is 2x squared and my g is y squared. So let's try and do that. So first, differentiation of the first is going to be 4x multiplying the second, which is g, so y squared, and then adding the first normal, which is 2x squared, and then multiplying the differentiation of the second. What's the differentiation of y squared? It's going to be 2y, and then we have to multiply by dy by dx. This is equal differentiation 1, which is 0. So this over here is going to be 3 plus 4xy squared plus 2 times 2 is 4x squared y, then multiplying dy dx. So I can move this and equal 0. So I can move these to the other side. I'm going to have 4x squared y dy by dx equals minus 3 minus 4xy squared. I'm gonna divide everything by 4x squared y, 4x squared y. So dy by dx, these are going to cancel, is going to equal minus 3 minus 4xy squared over 4x squared y. So this is how to find dy by dx. Let's try and solve another question. So let's say we have something like this. We have 2x cubed equals 3xy plus 1 all to the power of 2. Okay, so let's start by differentiating every single term alone. So differentiation of 2x squared is going to be 3 times 2 is 6, then x squared equals, okay, this is an example of a chain rule. So again, I have videos for the chain rule, please go check it out. But the differentiation of this is going to be differentiating this as a whole. So 2 times the coefficient, which is 1, so 2 times 3xy plus 1, and then we reduce the power by 1, which is basically to the power of 1, and then we multiply by the differentiation of what's inside. The differentiation of what's inside is the differentiation of this plus this. Okay, so what's the differentiation of the inside? Differentiation of 3xy. This is again a product rule example. So it's going to be differentiation of the first, this is f, this is g, differentiation of the first, which is 3, multiply g, and then adding to that differentiation of this the first normal, so 3x, multiplying the differentiation of the second, which is differentiation of y is 1, multiplying dy by dx. Okay, and then differentiation of 1 is basically 0, so that is it. So from here, what I can do is I can say that 6, or I can cancel this 2 with this 6, so this is going to be 3x squared equals, and I can multiply these out. So I'm going to have 3xy times 3y is basically 9xy squared, and then 3xy times 3x dy by dx is basically plus 9x squared y dy by dx. And then I'm going to multiply this 1 inside, so plus 1 times 3y is 3y, plus 1 times 3x dy by dx is 3x dy by dx. I'm going to move everything that doesn't have a dy by dx to the other side. I'm going to have a 3x squared, gonna move this minus 9xy squared. I'm gonna move that, so minus 3y equals 9x squared y dy by dx plus 3x dy by dx. From here, I can take dy by dx common. So this whole thing divide dy by dx is basically 9x squared y. The same thing for that, so it's going to be plus 3x. And this is equal to 3x squared minus 9xy squared minus 3y. Dividing both sides by 9x squared y plus 3x. This is going to give me dy by dx equals basically this dividing 9x squared y plus 3x. So it's going to be 3x squared minus 9xy squared minus 3y over 9x squared y plus 3x. So what I can do from here is basically I can see that I can divide 3 from everything. So this is going to be 1, this is going to be 3, 1, 3, 1. So this is going to equal x squared minus 3xy squared minus y over this 9 divided 3 is 3, x squared y plus x. And this is going to be my answer for dy by dx. Let's take another example. Let's say we have sine 2x squared y cubed equals 3x cubed plus 1. So let's differentiate that implicitly. So first we're gonna start by differentiating the sign. So it's gonna be cosine of what is inside 2x squared y cubed, and then multiplying the differentiation of what's inside. So the differentiation of this again is a product rule. So I'm gonna have differentiation of the first, so 4x, then the second normally, then adding to that the first normal, which is 2x squared, and times the differentiation of the second, which is going to be 3y squared, and I cannot forget to multiply dy by dx because I'm differentiating y with respect to x. This is going to equal differentiation of 3x cubed, which is 9x squared, and differentiation of 1 is basically 0. What I can do from here is I can multiply this cosine 2x squared y cubed inside. So it's going to be 4xy cubed multiplying cosine of 2x squared y cubed plus this term multiplying this term over here. First of all, I'm going to have 2 times 3, which is 6 x squared y squared dy by dx multiplying cosine of 2x squared y cubed. This is all equal to 9x squared. And what I can do is move this to the other side. So it's gonna be 6x squared y squared dy by dx cosine 2x squared y cubed. This is y cubed, okay, equals 9x squared minus this term over here. So minus 4xy cubed cosine 2x squared y cubed. And then I can divide everything by anything that's multiplying dy by dx. So I'm going to have dy by dx equal to this whole thing, which is 9x squared minus 4x y cubed cosine 2x squared y cubed over 6x squared y cubed cosine of 2x squared y cubed. Let's see what we can do from here. I can see that every single term has an x, so I can divide x from each term. So I'm gonna have at the end 9x minus x here is gone, so it's gonna be 4y cubed cosine 2x squared y cubed over 6x y cubed cosine 2x squared y cubed. Sorry, this over here, this part over here was 6x squared y squared. I don't know why I changed it to y cubed. So this is supposed to be y squared. So when we divide, this is going to be also y squared, and over here this is going to be y squared, and this is basically the answer. Right. Let's take another example. Let's say over here we want to find not the first derivative, but it says find the second derivative of the following function, which is 4y squared plus 2 equals 3x squared. So first we need to find the first derivative and then differentiate it to get the second derivative. So let's keep doing the same as what we were doing. So 4y squared times, so differentiation of this is going to be 8y, and as you know, multiplying dy by dx, then plus 2 is basically 0, and then this differentiation is going to be 6x. So from here I can see that dy by dx is going to equal 6x over 8y, which is basically divide by 2, 3 over 4, 3x over 4y. This is dy by dx. So now I will need to differentiate this again in order to find d squared y by dx squared. Okay, so the differentiation of this is going to be, so d squared y by dx squared is going to be the differentiation of this, which is, okay, I can see that this over here is a quotient rule. Okay, and I know when I have an f over g and I want to differentiate it, this is equal to f dash times g normal minus f normal times g dash all over g normal squared. Okay, and I had a video on this, please go check it out as well. So let's do that. So this is basically f and this is g. So f dash is going to be 3 multiplying g, which is 4y, minus f normal, which is 3x, multiplying g dash, which is going to be differentiation of this. So the differentiation of 4y is basically 4 multiplying dy by dx. Whenever I differentiate something that has a y in it with respect, and I'm differentiating with respect to x, I will need to multiply the differentiation at the end by dy by dx, as we've been talking about, and all of this is over g squared, so it's over 4y all squared. Okay, so let's try and simplify. So this term over here is going to be 3 times 4, so it's 12y, minus 3 times 4 is also 12x. Okay, then what is y by dy by dx? I know from here that dy by dx is basically this, 3x over 4y. So I can substitute, instead of multiplying dy by dx, I can multiply its equivalent, which is 3x over 4y. And then over 4 squared is 16y squared. Okay, so over here I can straight away divide 4 from everything, so it's gonna be 3y minus 3 and then x. Okay, so this is gonna be 3 multiplying 3, so it's gonna be 9, because 12 divided 4 is 3, multiplying 3 is gonna be 9, then x times x is x squared over 4y, and all of this is over 16 divided 4 is 4y squared. So what I can do is I can multiply up and down by y to get rid of this y in the denominator. So this is going to equal 3y squared minus 9x squared over 4y cubed. And this is basically going to be my answer for the second derivative. I hope this video was helpful. Please don't forget to share the video, like, comment your suggestions and questions down below, and most importantly, don't forget to subscribe to keep me going and doing more content for you guys. Anyways, thank you for watching and have a nice day.